A few chapters ago, we looked at linear equations, and we said the standard form for a linear equation was ax plus by equals c. So it's a combination of numbers and variables, but the variables were all to the first power. Today we're going to take a look at quadratic equations, and the general form for a quadratic equation follows ax squared plus bx plus c. So again, we have combinations of both numbers and variables, but now the highest degree or the highest power that we see is degree 2. So all quadratic equations are going to have a degree of 2. Now, the standard form of a quadratic is always written in decreasing order. That means we're going to write the squared term first, followed by the term that has the variable to the first power, followed by the constant. All right, let's take a look at a few examples for today. Example 1 says to multiply these two binomials. When we multiply binomials, you may have learned the FOIL method. First outside, inside, last. However, a better way to think about it is the distributive property. We need to distribute the x from that first binomial to both of the terms in the second binomial. So x times x gives us x squared. X times a positive 3 gives us positive 3x. Next, we're going to take the second term, which is negative 7, and distribute it to both of the terms in the second binomial. So that's negative 7 times x, which is negative 7x, and negative 7 times a positive 3, which is negative 21. Now we'll combine the like terms in the middle here, so we end up with just 3 terms, x squared minus 4x minus 21. So this is known as a trinomial because it has 3 terms. It's a quadratic because it has a second degree power, and it's written in standard form because the powers are in decreasing order. All right, in example 2, we're asked to square the binomial. Now, this is also known as expanding a binomial. And what we're going to do is we're going to first do it by hand here on the left-hand side, and then we're going to fill in this little graphic organizer or this visualization. So when we square something, we multiply it by itself. So we're going to multiply the binomial x plus 5 times x plus 5. We'll follow the same method as we did before. X squared plus 5x. And then we're going to distribute 5, so we get another 5x plus 5 times 5, which is 25. We combine our like terms in the middle, and our quadratic equation is x squared plus 10x plus 25. Now, if I square something, squaring something really means you're just multiplying it by itself. So I'm going to create a square in which one side is the expression x plus 5, and the other side is the expression x plus 5. Now, if I multiply these rows by these columns, I'm going to fill in these boxes. X times x is x squared. X times a positive 5 is positive 5x. Likewise, here in row 2, column 1, I'm going to have 5x and then finally 25. You'll notice in each one of these squares, we have the same terms that we did when we multiplied or squared or expanded this binomial. So if I combine our like terms found on the diagonal here, we'd end up with this same trinomial, x squared plus 10x plus 25. Example 3 is just like this. Why don't you pause the video now and see if you can tackle example 3 on your own. All right, our previous 2 examples should lead us to this discovery of the binomial square theorem. And it simply states if we square a binomial, for example, x plus y squared, the result will be the first term squared plus 2 times the product of the 2 terms, x and y, plus the square of the third term. The second term. So that's y squared. Now, that's in the case of x plus y squared. In the case of x minus y squared, what we get is our first term squared minus 2 times the product of the 2 terms x and y plus our last term squared. All right, so let's apply this binomial square theorem here to a few problems. If I take a look here, I'm going to expand or square the binomial x plus 8. Well, my 2 terms are x and 8, so I'm going to simply follow my pattern here. The first term squared is x squared plus 2 times the product of the 2 terms, which is 8 times x, plus the last term squared. All right, simplifying that now, I would get x squared plus 16x plus 64. All right, let's apply that now to a little bit more of a difficult problem here. We have 3 times the quantity x minus y squared. Now, we had x minus y squared right up here. So what we can do is actually just copy that same thing down and then distribute our 3. So we'll have x squared minus 2 times the product of x times y plus y squared. And now we'll distribute the 3 to each one of those terms on the inside of the parentheses. So that results in 3x squared minus 6xy plus 3y squared. Okay, now there was one more example on your notes, and we're going to tackle that example here. We're going to write it in. We have 2x plus 5y, and we are going to square that. So again, this is a binomial. I have 2 terms here, and we're going to follow the pattern of where we have our plus sign between those 2 terms. So our first term will be squared, so I'm going to write 2x in parentheses, square that, plus 2 times the product of our 2 terms, so that's 2x times 5y, plus our last term squared. So I'll put 5y in parentheses here and square that. Now we need to simplify this expression. When I square a 2x, I have to square both the 2 and the x. So that results in 4x squared. Next, we have 2 times 2, which is 4, times 5, which is 20. So that gives us 20xy. Finally, plus 5y squared. I need to square both the 5 and the y, so that turns into 25y squared. So this is example C that you can find on your notes there. All right, let's take a look at another example here. In example 5, it says a portrait is 20 centimeters by 90 centimeters. So we're just going to draw ourselves a little picture here. Here's 20 by 90. Beautiful little picture of Uncle Fred. Here he is, his nose, his mouth, his skinny little neck, and he's playing soccer or something. I don't know. And it's a beautiful sunshiny day. There's our picture. Anyways, we have a frame around this portrait that's f centimeters wide. So first of all, this dimension here is 20, this dimension here is 90, and now we have a frame around it, and that frame measures f centimeters wide. So let's take a second. There's our beautiful frame, and its dimension right here is f. And same thing with this width here, it is also f, which means this distance here is f, and same with this distance, even though it looks a little bit longer than f. But anyways, regardless, here we go. We want to write the total area of the portrait. Now remember, area for a rectangle is length times width. So we need to write an expression for the length and width. I'm going to change up some colors here so you can see what we're doing. Let's talk about the entire width across here. Well, we know that this amount here, from here to here, is 20, but on each side we have an f and an f. So that length really is 20 plus 2f. All right, now let's talk about the height of this here. Well, the height, we know from here to here is 90, but I have to add on to that, again, an f here and an f here. So this expression for the height is really 90 plus 2f. So here's our length, here's our width, or our height and our base, or whatever you want to call them, our 2 dimensions. We're going to multiply them to find our area. So this is just multiplying 2 binomials. We'll use our distributive property. 20 times 90 is going to give us 1800. 20 times 2f gives us 40f. Now we're going to take 2f and distribute that to both of those 2 terms there. We have 2f times 90, which is 180f. And then 2f times 2f is 4f squared. All right, we should simplify our expression and write in standard form. So keeping in mind standard form, we're going to start with the highest variable first. Our area is 4f squared, I should say our highest degree, plus 40 and 180 give me 220f plus 1800. And here is our expression for the area of that beautiful portrait of Uncle Fred.